Hello everyone. So in this lecture we are going to talk about circular queue. As the name suggests, the queue will be circular in nature. That means after your last position it will connect to the first position, or you can say the last index connects to the first index. We will see that there are certain drawbacks in the linear queue, and to remove that drawback we come up with a new concept called circular queue. So this queue allow us to make use of optimal allocation of all the available spaces within the queue. We will see in more details. So let's start. Okay, let's talk about the drawback of linear queue and which gave rise to the circular queue. You will see here that once the queue is getting full, you are not allowed to insert more element, and this is actually not conforming to the real life scenarios. Now, if you find in any place where the queue is maintained, or you can see, let's say there's a bench is there which actually is placed in the shop for the customers who are in the queue. So let's say there are 1 2 3 4 5. If the five chairs are there which actually allows the customer to sit here and then wait for their turn. Now what is happening? Let's say the first customer sits here, then second sits here, then third sits here, and fourth sits here, and fifth sits here, right? Means at any point when all the chairs are occupied, and we are saying that this is full. If you call it this is the queue, then the queue is full. Now, in the real life, what is happening? If let's say this person get its turns, it's actually vacate this chair, and then this person get this turn and vacate the chair. So that means these two positions are actually vacant, these two chairs are vacant, which should be occupied by the other customers who want to the part of this queue. But actually in the linear queue, what is happening? Once you reach to the scenario when all the chairs are occupied, even now these two chairs are vacant, it will always says that there is no place to sit. Means your queue is always remains full if once at any point of time if your all chairs are occupied. So this is actually the drawback which is not conforming to the real life situation, and it is also not allowing us to optimally use all the spaces, all the places. So if we have five places, then at any point of time we must accommodate all these five positions or five places. What does it mean? It means, let us understand in a different way. Whenever you are inserting the element, you are always incrementing the rear pointer or the rear index. So rear will be rear plus 1 whenever you insert, and we always check the rear. If rear equals to max minus 1, then we say it's the overflow scenario. What is happening? Let's say this is the scenario 1 2 3 4 5 6. So we have a queue of size 6, that means it goes to index 0 1 2 3 4 5. And let's say if you insert some value a, so initially when you insert the value, you will point this front and rear will point to this, and next time onwards when you insert any value, let's say b, then rear will point to this, then c, rear will point to this, then d. At every time when you insert, you will always check, is rear equals to max minus 1? So max minus 1 is 5. So is rear is pointing to fifth index? No, that means you are allowed to insert. So you will increment the rear and you will insert a new value. Now again, if I want to insert a new element f, I will check if rear equals to max minus 1. No, I will increment it, and then I will insert. Now rear pointing to this. Now every time when you are inserting, you simply look to the rear, and based on that you are doing your operation. Now let's say after inserting a b c d e f, and if I made two deletions, so this element will be deleted, because every time when you delete, your front will be taken care. So you always look to the front. So you look to the front and you delete this, you will bring this out, and now front will point to this. Okay, so let me make this clean. So when you delete this, front will point to this. Now again, when you delete this, the front will point to this. So what you observe, you will observe here that front is pointing to this element. Now if I want to insert any more element, you will look to the rear, and rear will say that it is max minus 1 because rear is actually pointing to 5 index, which is the highest index. So it will say that your queue is full, but actually the queue is not full. Still you have two more positions to accommodate more element, but as per this logic it will say the queue is full, which is actually a drawback or a limitation of a linear queue. So we have come up to the linear circular queue. Now circular queue will allow us to use all the spaces which is available. So at any point of time you are actually in a position to use the entire size of the queue which is given to you. Now, so we have understood what is the drawback of linear queue and how it can be going to resolved by the circular queue. Now this is how a circular queue will look like. This queue is not linear but circular, that's why its name is circular. So you can see it will look like this figure, and once the queue is full you are allowed to insert the element to the first index, provided this index must not contain any value. For example, if you look to this scenario, if I want to insert any element, it will check that what is the status of the next index. If there is no element, then you are allowed to insert the element. So this is what we are looking in the circular queue. So you can see that once you reach to this situation, and if you want to insert any more element, you are allowed to go to your next index, that is the first index, that is 0 index. So now rear is going to point it here, if provided this index must be, and this index position must be empty. So this is how the things will work. If this index is not empty, in that case only you will say the overflow. Overflow is only identified when the next index is going to be occupied, then only it's overflow. It's not based on the max minus 1 condition that we are using in the linear queue. Okay, so let us see that how the things will work. Okay, now we look to the algorithm of insertion. So we will see one by one that how these implementation can be performed. We know that implementation can be done by the arrays and by the linked list. So first we will see that how this implementation can be done using an arrays. We will see two operations. One is insertion, we call it enqueue and dequeue. So first we see enqueue operation. So this is a procedure, we are calling it the insert circular queue, and we need to pass some parameters. CQ, that is the circular queue, our circular queue which holds the items, the status of the rear variable, the status of the front variable. Keep in mind, front points to the first element, rear points to the last element. Front is used when you want to delete element, rear is used when you want to insert element. N is the size of this queue, and item is the element which you want to insert in this queue. So these are the parameters that you need to provide. So here you can see, when you want to insert, this pointer need to be checked to be inserted. Front is always used when you want to remove something, and will tell you the size of the queue. Item is the new item that you want to add. Initially, when you start working with the queue, you always initialize the rear and front as -1. So if you any point of time, if you find that your front is -1, that means actually there is no element added into your queue. Now if front equals to -1 and rear equals to -1, that means your queue is empty and no element has been added, and you will set front equal to 0 and go to step 4. So when you come here, you will see here. So let me just remove this here. Actually first you have to increment the rear. You need to increment the rear index by 1, and then you have to write the statement CQ rear equals to item. So first you have to increment the rear. So rear is actually -1, it becomes 0. and at the 0 index you will write the item and you will return, you will stop. This is a scenario when you are going to add your first element, but there may be various scenarios are possible. So first scenario is if it is going to be first element, you do this thing. Otherwise, if this is not true, if front equals to 0 and rear equals to n minus 1, that means your entire indexes are actually occupied. This means your entire queue is being filled. Okay, because your first index and the last index has been occupied. So if any point of time, if you find the last and first index, the last index have been pointed to by the front and rear, that means your queue is full. Otherwise, if front equals to rear plus 1, then also your queue is full. Now keep in mind, there is a possibility index 0, 1, 2, 3, 4. If you insert the first element here, we call it the front, and then you insert second, third, fourth, and you insert all the element here, and this is rear. Now if you find here that elements, there is no space vacant. Okay, so this is the scenario when front equals to 0 and rear equals to n minus 1, then it is full. Otherwise, if front equals to rear plus 1, then also it is full. What does it mean? It means, let's say you delete the item. So you delete this item. This is actually vacant, and now front will point to this. Okay, this is front. Now if you insert one more item, so if you insert one more item, then what will happen? You will be going to insert it here because it's circular. So you will insert here and rear will point to this. Now this is no more a rear, and rear will point to this. Now if you delete one more item, so delete will always be done at the front. So whenever you do the delete, you always increase the front pointer. So you delete this item, this becomes empty, and the front is here. Now if you want to insert one more item, so now whenever you insert with the rear, rear will increment, and you insert the item here. That means now rear is this and front is this. Now if you look at this, you will find that at this point of time all are occupied. So how we can identify that all are occupied? One condition is if the front is 0, rear is n minus 1, this is occupied. The other condition is if front equals to rear plus 1. So at any point of time, now front is what? Front equals to 2 and rear equals to 1. So if front equals to rear plus 1, if you find this condition true, then also it is said to be occupied. Or you can say when the rear is just behind the front, then also it is occupied. But how can you see? Because this is graphically we are looking here, but when you're writing a program, how you can verify the situation? You can verify using this logic, front equals to rear plus 1, and this is a case of overflow. Now if this is not true, means this is not the first element, your all cells are not occupied, it is not overflow, then what is required? If rear equals to n minus 1. Now normally whenever you insert any element, you simply increment the rear. So means if your rear is at 1, you becomes to 2. If your rear is 2, you go to 3. If your rear is 3, you go to 4. But if you look at the scenario, if your rear is at 4, then you cannot go to 5 because there is no 5 index. So that means if the rear is pointing to the last index, in that case you need to go to rear equals to 0. Okay, so keep in mind whenever your rear is pointing to the last index, then you need to go to the very first index, which is rear equals to 0, and then you have to insert the element in this step. So instead of writing this, you can write here CQ rear is equals to item. The meaning of the statement is that you have set the rear, and at this index you are going to insert the item. Okay, just remove this, is not required here, and return. Now this is a scenario when your rear is pointing to the last index. Now if this is also not true, Then what is required? If none of the thing is true, then you go to step 4 directly, because none of the things are matching. Here what is required? Simply add the rear index and insert the item. So in general, what we are doing, we are simply incrementing the rear and inserting the item. But before doing this, we need to also verify all the different scenarios, which is very important. Okay, this is all for inserting the element. Now let's see how the dequeue will be done using arrays. Okay, this is a delete operation. We call it dequeue, and here we are using one procedure called delete circular queue. We pass some parameters here. Now, circular queue is a queue which actually we are working with. Rear is pointing to the last location which we are actually using where the element to be inserted. Front will point to the first element where we are using to delete the element. And item here is one variable we are using that will be used to store the element which we are deleting. So the operation is delete. So when you delete some value, that value is going to be stored at item variable. Okay, if the front equals to -1, means your queue is empty and still you are performing the delete operation, it will say underflow and you will stop. Otherwise, if the queue is not empty, then definitely you are allowed to delete. Then what you will do, whatever the front is pointing, that index you will assign to item. Item is the variable that we have passed that can hold the value which we are deleting. So this we are deleting. Now, if front equals to n-1, now we have certain scenarios are there. If front equals to n-1, that means front is pointing to the last index. n-1 is the last index. Then set front equals to 0 and return. So the scenario is this is your circular queue, index 0, index 1, index 2, index 3. Let's say front is pointing to this. In general, what we are doing, whenever we delete anything, we always increment the front. For example, if this is, let's say front is pointing, not this, front is pointing to this index. Okay, so when you delete the element, you will delete the element and now you increment the front. Now front will point to this. So every time when you delete any element, you will always increment the front variable. Now here the scenario is different. Let's say the front is pointing to the last index. Now in this case you cannot simply increment the front, because if you increment the front, it will move to index 4, but there is no index 4 existing. So whenever you are your front is pointing to the last index, then you set your front to 0, means it goes to the first index, it points to the first index because the next index is 0, and stop. If front equals to rear, now front equals to rear is a scenario when you have only one element existing in your queue, and if you are going to remove this element, then your queue is going to become empty. So if this is a scenario, that means only one element exists. So keep in mind, whenever the front equals to rear, this is a scenario when only one element exists in the queue. In this case, your queue is going to become empty and you will set front and rear equals to -1 and stop. Otherwise, if nothing is happening, in general, what we are doing, simply increment the front index. So as we have seen that when the front is pointing here, we move to here. If the front is pointing here, we move to here. So in general, we simply add the front to the next index. So this is how we can apply the enqueue and dequeue operations using array. Let us now have a look at how these algorithms can be applied on any real scenario. So we will take one example and we will see that how this algorithm will work for insertion and deletion operation.